A stone is thrown horizontally at 22 meters per second from a point 1.5 meters above the ground. Calculate the horizontal distance traveled by the stone before it hits the ground. So like all mechanics problems, drawing a diagram is quite important. So if we've got a man here, he throws a stone at a speed of 22 meters per second horizontally, so the angle will be 0 and his height is 1.5. This will be sort of the projection of the stone, and it will land X meters away from him. Now, this is going to be modelled by projectile motion, and where the angle with the horizontal will actually be equal to 0. So we can use the same rules as normally. So vertical motion will be y is ut sine theta minus a half gt squared. We need to find the time where the stone hits the ground, and that will happen when the stone has gone down by minus 1.5 meters. So putting minus 1.5 equal to the initial speed, 22 times time times the sine of 0 minus a half gt squared. Sine is 0, so this bit will be 0, so we're going to get 1/2 gt squared is equal to plus 1.5, moving the minus signs. Rearranging that, we get that t squared will be 2 times 1.5 divided by g, and to find t we need to take the square root of that, which my calculator will give me in third form root 15/7 seconds. It's better at this stage probably to keep it in third form. Now, in order to find the horizontal distance for projectile motion, x will be ut cos theta, and therefore x will be 22 times the square root of 15/7 times the cos of 0. The cos of 0 is 1. So we need to work out 22 times the square root of 15/7, which gives me 12.172, which correct to 3 significant figures gives me 12.2 meters. So this has been a video to show you how to find the horizontal distance travelled by a stone which has been projected horizontally, acting under gravity. I hope you've understood, and I thank you very much for watching.